our next speaker is Aaron Richter. He's the senior data engineer at Squarespace. He's from Florida. He got his PhD from Florida Atlantic University. And what he's really passionate about is improving data science tools. Welcome, Aaron.
Great. All right, we're good. Okay. Well, thank you, everybody, for this conference. Thank you for coming, and thanks, organizers, for the opportunity to speak here. It's been several years since last kind of in-person conference experience and talk, so I'm really excited to get back into this. We're talking about SQL today, but we're also talking about data science, and I'll get into why we're doing that here. But I think this talk is going to be part like think piece, part case study, with some stuff that we've been doing at Squarespace. So hopefully I'll have some knowledge that appeals to everybody. I'll have some things that seem like no-brainers to some folks. I'll have some things that seem controversial to some folks. But I think that's the hallmark of a good talk. Some people come away like a little offended. So quick about me. Did have a quick intro, but just a little bit more. I'm a data engineer at Squarespace. I'm currently in New York City, but spent most of my life in South Florida. That's how I'm connected to this conference. Hobbies include volleyball, climbing, and I have a motorcycle. And I do sometimes use that in the city, but I mostly use it to get out of the city. You can find me anywhere on the internet with these 7 letters, R-I-K-T-U-R-R, so Twitter, LinkedIn, anything like that. I've been involved in the PyData conference series. I was the organizer for the Miami conference, so I wanted to give a plug for the next couple PyData series. There is one in Miami coming up in a couple of weeks. It's the 20-something. I don't remember the date exactly. And I'm also an organizer for the PyData New York City conference. So if you're interested, and that's happening in November. So just quick plug for those. They're going to be great events also. Some of my background on why this talk has kind of come to fruition is that I did a PhD in computer science and machine learning, but at the same time my title was data scientist at my job, but I was really a data engineer building data pipelines. I think there was a previous talk before that says you can't, or during the lunch panel today, you can't really have good data science practice unless you have good foundational data and BI practices. And so that's kind of what I was building at my first job. And I kind of switched more into the data science realm, working for a vendor in the space, and then have kind of swung back over to the engineering and analytics side. So I'm on the data operations team at Squarespace, and our responsibility is to manage tooling and infrastructure for analytics and data science teams. So the analytics side of the house, you can imagine SQL is a big part of that. Data science, Python, and SQL are both big parts of that. And so a lot of my time has been spent in the SQL world and the analytics engineering world. So I'm kind of trying to bridge those two parts of my experience into this talk. So when I say embracing SQL, I'm trying to say use more SQL, not just because you have to. OK, just a quick, nice intro. I think these talks are good platforms to kind of show what we're doing in the data science teams at Squarespace. These are kind of internal-facing applications. We do have machine learning teams that put products like features into our products. My kind of organization's not involved in that side of things, so I'm purely talking about kind of like internal applications. So some of the things that our data scientists here do, and I'm not going to go through each of these, but I'll give like a couple of good examples. For marketing, for customer lifetime value, that's kind of one way that we can figure out how much does the customer give us, and then if we tweak these levers, how much can that change? And so we'll do a lot of data science there, using kind of different kind of models to model churn is one big part of understanding lifetime value. We also do some cool work with website segmentation. So I actually failed to give a background on what Squarespace is, so I apologize for people who don't know. I'm always in this every day, and so I'm just assuming. If you're not familiar with Squarespace, We are most famously known for our website builder, so it's a way for people who don't know how to code who can build and publish websites. It's also known to be very kind of design-oriented, so you can make a really nice-looking website, and we have a lot of strong opinions about like how websites can look and how you can build them. But that's not the only thing that we do. Like, the main focus is to help like individuals and entrepreneurs and creators kind of succeed in their businesses. So we have a lot of e-commerce tools, we have a lot of email marketing tools, scheduling, ways to kind of make money off of different things that you're creating. So it's a great tool if you're trying to do something on the side and you need a website, come talk to me. Anyway, so that being said, main data point that we have are websites and the content of those websites. So to understand like what is a website about, we have to build models to understand. There's a lot of text processing and things like that to understand the content of the websites. That way we can know, is this about a restaurant? Is this about anything like that? And we also have a cool blog post about our A/B testing infrastructure, where we've kind of built out reusable ways for analysts and product teams to run A/B tests without having to interface directly with a data scientist every time. So it's a lot of reusable kind of tooling stuff. But that's data science in Squarespace. As far as, that's what, like, kind of the applications of data science in Squarespace. The technology behind the scenes, this is a very simplified diagram about kind of what's going on, but some of these tools are kind of important to think about as going through the rest of my talk. Our data starts somewhere, right? And those are various databases. Like, we have Postgres databases around. We have BigQuery for our data warehouse. We also use Trino to connect to various different databases as well, formerly Presto, if you're familiar with that term. And as far as the data ingestion and transformation side, a large part of my job lately has been working with dbt and building infrastructure for that. So if you're not familiar with what dbt is, it's basically a tool that brings software engineering best practices to SQL data transformations. So it's ways to separate production and staging environments, version control, reusability, functions and things like that. It's a big driver of some resurgence of kind of like SQL and a lot of workloads, as I'll talk about in a second. But we use that as our primary ETL data transformation tool. Moving over to the next two columns, this is really where data science comes in. We have several places where a data scientist is going in and using data and building something. The first is within several Python packages. We're a Python shop, but anything I talk about in this deck and in my talk, you can basically swap out Python for R, and it's kind of the same concepts. And then we use Airflow for orchestrating, whether that's model training, serving, scoring, well, not serving, model training, scoring, data transformations, things like that. We're using Airflow to orchestrate. But also sometimes people are just going directly into databases and running a SQL query. So maybe that's the BigQuery UI. Maybe that's tools like DataGrip. And then we're heavy users of notebooks through Jupyter. And so those are the tools that our data scientists will use. And the end products of those tools end up in the third column, like Looker as our main business intelligence tool. That's where we get all of our charts and where our users get their charts and everything. We use Streamlit apps for things that can't fit well into Looker when it needs a little bit more interactivity and it needs more customization with Python. And then there's always ad hoc reports, right? Somebody's running a notebook, running a query, giving a spreadsheet, giving a slide deck. And usually that's either starting from a database interface or a notebook. OK, so that was just some intros. Now actually into the meat of the talk. And I don't know why, but I always like to give some history lessons in a lot of my talks, and if none of the rest of it is interesting, I hope at least I could interest you with some of this history. And then basically talking about how we embrace SQL at Squarespace on the data science analytics side, and then kind of further applications of SQL that I am thinking about and would like to see, but we don't currently do at Squarespace. So I want to talk about how did we get to where we are now? How did we get to me talking about SQL at a data science conference, and also like me feeling weird about talking about SQL at a data science conference? I think you might know what I mean there. There's been some kind of like weird debates that I think are pointless about Python versus SQL, which one is better. It kind of doesn't really make sense, but I'll try to kind of give us some background on like how we got to the tools that we're at and how we got to some of these discussions. So in the beginning, there was data, right? So people were recording data, and where were they putting that? In databases. So this one is going to be the one portion that I'm not going to be super familiar with. I just Googled when was Oracle founded, and it was like 1970-something. I wasn't around back then. But we had data in databases, right? And it works really well. You had a structured way to query things. You could get data out. You could serve applications. This is the base, and this is really where SQL started, right? But then we move forward, not really after, but some things were happening in parallel, thinking about kind of, when I say Python and data, I'm really thinking about like computational like data science, like computational workloads, processing, things like that. The R kind of came up with this concept of a data frame, a way where you can collect data into an object in memory in a programming language and then perform statistical operations on it and other things like that. I mentioned that because Pandas was inspired by the R data frames. Pandas was started in 2009, and that brought data frames to Python. People were analyzing data in Python before that. People were using SQL to put data into Python before that. But Pandas really standardized the way that we do data processing, opened up a lot of applications. Like basically, Pandas is the entry point when you're using structured or tabular data, right? You're reading from a CSV, or even reading from a database, something like that. That's a big portion to kind of think about. Kind of swinging back to another side of the house is we have this like big data world. Nobody talks about that word anymore, and I'm glad because I always hated it. But back in like early 2010s is when it was really hot, when Hadoop came out. The reason why this world kind of phase started is because data was getting too big for those regular relational database systems. You couldn't kind of just handle the scale, right? There was so much data being created on the internet, and now these larger companies needed ways to analyze that. It couldn't just fit into a regular SQL Server Oracle database. And so what happened, though, is you lost a lot of stuff that you get from a regular relational database. You lose a lot of the constraints. You lose a lot of like indexing and kind of like all of those different things, especially back when it was just Hadoop and MapReduce. You just dumped data somewhere, and then you had to figure out how to write a job to query it. So as time went on, tools got better at analyzing these larger data sets. And if you look at the parentheses, people just started building SQL interfaces on top of these big data tools. Like Hive was a SQL interface on top of Hadoop. And then Presto was a way to query Hive tables faster. And then Spark came out and kind of revolutionized the way that we dealt with in-memory data processing. And then they eventually added SQL support there too, right? Because a lot of people use SQL. So I just wanted to highlight that. And then starting to get to kind of like what I'm saying where we are now is the cloud data warehouses started to come out. And so this was starting to bring some of the best of the relational database systems and these big data systems. Is now you don't have to deal with hardware. When you have a Hadoop cluster, you have to spin up a bunch of machines and nodes and to deal with all this infrastructure. Now with BigQuery, Redshift, and Snowflake, it's serverless. Now you have kind of endless possibilities to analyze your data as long as you have enough money, and you don't have to deal with infrastructure. You can run SQL queries on large data sets without like having to deal with all the problems that came with running Hadoop and with Spark. You don't have to set up Spark. You can just run a SQL query over terabytes of data, and you'll get the result back right away. And I think this is kind of a key driver for what also brought out the next phase, which is the kind of birth of analytics engineering, and DBT was a big part of that. So if you're not familiar with the term, it's definitely a newer term, but I'm seeing data science teams now split up into teams of data engineers, analytics engineers, data scientists, and analysts. Whereas before, data engineers were maybe doing some of the work of analytics engineering. Data scientists sometimes were doing some of that work. But the way that you can think about an analytics engineer is they're bridging the gap between data engineering and the business. So they understand like SQL, they understand how to extract data and transform data, and they also understand what the business needs, whereas a data engineer might be more separated from kind of the specific business needs. So I introduced DBT and what it is, but it was kind of built on the backs of these cloud data warehouses, because DBT is not doing any of the work. All DBT is doing is generating SQL and then executing it on something like BigQuery for you. But the reason why I'm telling this whole story and getting here is that DBT and analytics engineering has brought SQL back to the forefront to a lot of conversations. People are treating it as like a first-class language. They're learning how to optimize things. They're caring about it more instead of just writing a SQL query to get the data out of the database and they'll deal with everything later. There's an entire practice now around this, which is called analytics engineering, and a lot of the kind of like data thinking and Twitter people and stuff have been talking about it a lot, and then they all started talking, I don't know, somebody sent a tweet about like comparing saying how Python's better than SQL, and it's like, it doesn't really make sense to say that, and so that's what some of these screenshots of these tweets here are. But I'll let you kind of read through some of those, but there was just some discussion, and a lot of Some of the folks here that I've screenshotted are big folks in the analytics engineering space. A lot of them, kind of like modern data stack, like Ben Stansel from Mode. But a lot of people are have been big in the data science and machine learning space, like Aaron Bernhardson, Hamel Hussein. And they're all kind of confused by this. Like, wait, shouldn't we use both? Isn't one better for one tool than the other? And that's kind of what inspired this talk here. And I'm hoping that I can start to make sense a little bit of this. So the question here is why is my talk titled Embracing SQL for Data Science? Basically, what I'm proposing is to use SQL in more, just kind of deeper into the data science stack. Like I said, a lot of the times, the initial response to this talk might be, well, yeah, of course you have to use SQL because your data is in SQL and you have to run a SQL query to get your data out of the database. But a common thing that you might do is run a SQL query, download a CSV, and then pull it into pandas and do some more filtering and aggregation. What I'm trying to propose is to push a lot of that back up to the data warehouses because they're very performant now. You don't have to spend the computation on your machines, and you can now generalize that. You also open it up accessibility to more types of people and other roles of people who maybe aren't familiar with Python, aren't able to kind of set up Python on their machines, and things like that. And also, these ETL tools and pipelines are all kind of running SQL anyway, or generating SQL, or emulating SQL. So why not stay closer to that? The runtime problem is a really interesting consideration, and one of the tweets that I posted there was kind of talking about that. And it's Python itself is not really that hard to learn and write. Compared to SQL. The challenge is, and I deal with this all the time because I support data scientists and analysts that are at my company, is that just getting Python installed is a pain, especially on an M1 Mac. I don't know if anybody of you have one of those. It's horrible, right? And getting all the packages you need installed and then dealing with the dependencies between those and virtual environments and things like that. When you have BigQuery, you can just write a SQL query instantly in a web browser and you get your data back immediately. You don't have to think about, how do I actually launch a database? How do I run the server? How do I run a cluster? It just kind of works for you. And I'm hoping that we can start to kind of bridge those divides between the languages and kind of make them as strong as possible for their own needs. Okay, so now that was some of the thinking, and I hope I kind of made sense. If not, I'm going to go through a specific case study of a project that I worked on during one of my hack weeks at Squarespace and kind of inspired this talk, and that's kind of built the talk kind of around this project. But as far as embracing SQL, this is kind of trying to treat SQL as a first-class language at Squarespace. So some of our goals for this is we want to streamline data access. We don't want people downloading files to their local machines. That's a security problem. It's also just not performant. We don't want to have to deal with really inefficient data manipulation on your own computer, installing packages that maybe aren't available on the servers that you're deploying your packages to. And you don't want to have to rewrite any code when you go to production, right? But we want people to also be able to use familiar development environments. We want to co-locate the Python and SQL code for the most efficiency, and we want all that code to be kind of production ready. So that's what we're trying to do here. So we split this up. This is basically split up into two kind of categories of basically internal products that we've created. So we have this suite of connection packages in Python that you would use when writing kind of production code. And then there's a package called Jupyter SQL, which is one that I worked on, which is for when people are using notebooks. But first we'll get into connection packages. Mostly this is just helping to eliminate some boilerplate code anytime you need to access data from your database. So if you see here, this is an example of actually one of the packages that we have called pcon for accessing Presto. And it takes one line of code to connect to the database, and then you can go ahead and execute queries and you get a data frame right away. It basically is wrapping SQL Alchemy, but it allows people to use consistent APIs, and the same exact code would run in production. You can put this in a Python package, put it on an Airflow or a Kubernetes operator, and it'll run right away. So some of the background for this is mostly that we're just abstracting away a lot of these extra SQL Alchemy lines of code. And it doesn't look like much, but when somebody's new to the company, new to doing this, it's really nice when you can just run an import statement and run 2 lines of code and then get your data instead of having to think about, oh, I have to install this and I have to configure this engine and what kind of format does my query need to be in and all these extra boilerplate stuff. Let's just kind of get rid of all of those things. So the other thing that I worked on is this Jupyter SQL package, and the goal of this is to make SQL a first-class language inside of Jupyter notebooks. So in a Jupyter notebook, you're used to getting things like syntax highlighting, autocomplete. It's it's made for Python, right? And you get all of the benefits of a notebook is you have your documentation there, you can have your code in the same places, and you can keep kind of execution output and things like that. But the goal for this was to remove the need for a separate IDE for doing your database work. So I mentioned like the BigQuery UI or a tool like DataGrip. People would write a bunch of SQL queries in there because you have all of those nice things that you get from an IDE, autocomplete, table lists, syntax highlighting, and then they would copy and paste that query into a SQL string for those other packages. And so it doesn't seem like much, but it is a very inefficient workflow, right? Let's say somebody's doing a code review on your Python code and they say, oh, fix this thing in your query. Now you're just changing code in there and you're not getting the same kind of syntax highlighting that you would get from your IDE. So this is what this looks like. In the middle is just like a configuration file where you would put your credentials, and on the right is a screenshot of this actually being used in a notebook. So there's this SQL Magic where you do %% SQL, and you tell it which connection you want to use because we use several different databases there. And then now you can, excuse me, write your SQL code. So you get a few things that we notice here is you get SQL syntax highlighting, which you wouldn't normally get in a Python string, and normally it would just all be purple, or, right? Is it purple? Green? And you get formatted table output. You get interactivity with Python, which I think I show you here. Yeah, so you can also get interactivity with Python. So if you notice on the very top right, I have a Python variable, and I'm injecting that into my SQL query. So it's really helpful for when you're kind of going back and forth. You need kind of variables in SQL. You could also dynamically build queries. Let's say if you needed to run the same query on kind of multiple different tables, you can inject the table name or kind of build the SQL query dynamically, which is something that a lot of people end up doing anyway, but now you can kind of see it a little bit better. And then you can get those results back into data frame as well. A couple of things that I wanted to work on and wanted to try to finish but haven't gotten it yet is autocomplete, so that way you can autocomplete table names and things like that, as well as having a widget inside of Jupyter Lab on the side where you can see all of the tables in your database. I think that would bring this package all the way through to completion of where you don't actually have to use any other kind of database IDE. You can just stay within the notebooks. So this package is mostly a collection of other open source packages, and I want to make sure to kind of list all of those here. The code that I have on the right is actually almost everything that you need for the package, besides listing what your requirements are to install it. Jupyter SQL currently isn't open source, but I'd like to do that at some point in the future, and we'll kind of work on that. But the major package that we rely on here is this IPython SQL package. This is what gives the SQL Magic and the credential management. So we also use this Jupyter Lab LSP, Language Server Protocol package, which gives you way more than syntax highlighting for SQL, but one thing that it has out of the box is syntax highlighting for SQL. iTables is a really cool package that I like, and it basically is a Python wrapper around data frames around the data tables JavaScript package. And so what this does is gives you really nice interactive formatted output, so you can sort records, you can search right inside of your notebook from your SQL query output. And then of course we have our regular database connection packages, but then all of these things are abstracted away from our end users. We get a new analyst that starts tomorrow. They can just run import Jupyter SQL and start querying instead of having to think about all of these individual different things. Okay, so that's kind of what we've done at Squarespace, and I'm going to caveat the rest of this presentation with these are my own opinions and not those of my employer. This is where I want to include SQL more, and this is where I'm going to try to maybe get a little bit spicy with some of my takes here. The first thing I'd want to say is that notebooks are a major part of data science workflows, right? And I just talked about a major application for Jupyter notebooks because that's what we use at Squarespace. But there are very recently a lot of notebook tools that are doing a really good job at Python support and SQL support and interacting between them, like authenticating with databases, and it makes it really seamless to kind of use both of these technologies, both SQL and Python together in the same place. It also helps with that runtime problem, right? If you have a cloud-based notebook, you can start instantly writing Python and not have to worry about installing it on your machine and things like that. So there's some free ones. Obviously, Jupyter is one, but you have to figure out how to install that. Google Colab is a free one that a lot of people, especially like people who are learning and students, use. But the two that I want to highlight here are DeepNote and Hex, are both two startups in this space that I think are doing a really great job with their notebook environments. In a previous company, we were users of Databricks, and I really loved having the notebooks just kind of online in the cloud already through them. And these two basically do that except without the Spark. So it's great. The last thing, and I guess this might be one, or not the last thing, I have two more. One of the other things is like, I used to think it was a terrible idea when I would see packages trying to do machine learning in SQL. And I think I'm starting to change my mind. I'm not completely convinced on that. So I'm mostly posing this as just like some discussion and some food for thought, is that you can do machine learning in SQL now. So I've seen a theme of like a lot of these talks at this conference is about simplicity, using simpler models, right? Try the hammer first. And if you really just need to do like a really simple logistic regression model and your data's already in SQL and all of the records that you want to score are already in SQL, just go ahead and do it. Like some data scientists are going to get mad at you, but just do it. The business needs it, right? So like, of course, there's all the caveats of like, make sure you're actually doing things, make sure assumptions are met and like all of those stuff, right? But you can do it. Also, the one other aspect of doing machine learning in SQL is what I mentioned before, is like accessibility. This now allows other people who maybe aren't necessarily trained in Python to not just do machine learning, because maybe they'll need some expertise from a data scientist to be able to actually do it, but they can see the code, they can understand like what's happening behind the scenes instead of the machine learning model being a complete black box and then not understanding what to do. They could also more easily score new records if the machine learning model is available somewhere in SQL. And then the last thing I'll talk about is Python models inside of DBT. So I talked about DBT, and I know some people in this room aren't going to necessarily be familiar with it, but I think this is a pretty interesting and development for incorporating and kind of bringing together more of the ETL pipelines, analytics engineering pipelines, and kind of data science and machine learning pipelines. Because they all have to be orchestrated in, so let me tell you what DBT Python models first are. Basically, a model in DBT is basically just a SQL query. It creates a table. And so now they're expanding to be able to support Python inside of one of those models. And the key is that you can layer dependencies between your SQL tables and your Python model. So let's say there's a Python model that has to retrain a machine learning model every time the data gets updated. Well, the data already gets updated on a schedule based on DBT. So why not use DBT to also know about that and then orchestrate that, and then everything now is connected instead of having to have like awkward airflow sensors to sense the presence of a table or updated record in a different place. You can kind of put it all together. And I linked to a talk very recently by Drew Bannon, who's one of the co-founders of DBT, talking about DBT and Python. He'll give a much better talk about this. And I just found this last night, actually, when I was Googling DBT and Python. So he might just give a better talk about the entire thing that I was just talking about today than me. So go ahead and watch that. The video is there. So that's kind of concludes my talk. One thing I want to say is that we're hiring at Squarespace. Within kind of my teams, we're hiring software engineers just across the business, some ML engineers who are working on kind of product ML stuff that I didn't talk about today, as well as data engineers within the kind of internal data group. And things are always changing, so feel free to just like add me on LinkedIn, find me on Twitter if you're ever interested in the future. We're based in New York City, but we're kind of hiring remotely across the board now. So definitely let me know if you're interested. And with that, we'll say thank you. And I'll take any questions.
Thank you, Aaron. We have time for just one question. It better be a good one. Anybody have one question?